Hello students, welcome back to JEE Last Mile Preparation Series 6. Today we will take up questions 11 and 12. But before I do that, by now you already know that I'm Sujata from CBSE NEET JEE Chemistry.in, and we are bringing 2 questions every day until April 4th to help students get that extra edge for their JEE chemistry exam preparation. To keep me motivated in this task, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is given in the description below. Let's get started. Today we start physical chemistry. All right? And the first chapter that you've studied in class 11 is some basic concepts in chemistry. It is a numerical oriented topic. So here is the first question, or question number 11. First question in physical chemistry, or question number 11 in the series. Let's understand this question. Okay? A 15% acetic acid solution is mixed with a 3% acetic acid solution. In what volume ratio should these two solutions be mixed to get a 10% solution? So that is the question. 4 options have been given here. So one of the 4 options will have to be chosen. Correct? All the percentages are given with respect to mass percent. So mass percent is a way to express concentration, one of the ways to express concentration of a solution. Let's understand this question. You've been provided with 2 acetic acid solutions. So 2 solutions of the same substance but of different concentrations. And the resultant, the concentration of the solution after the mixing of these 2 given solution is 10%. All right. So how do we progress or proceed with the calculation? Now the solution, the method I'm going to use here involves very less calculation. It can be done by using too many numbers, but we're avoiding that in order to save time. All right. So let's start with the calculation. So here we have 2 solutions, okay? So the concentration of the final solution after the mixing of the 2 solutions will obviously be the total number of moles. The total number of moles of acetic acid in each of these solutions divided by the total volume of the solution. That is, combining the volumes of the 2 solutions, total volume of the 2 solutions. All right. Now, the total number of moles would be N1 plus N2, right? N1 plus N2, correct? And that divided by the total volume V would be equal to the final concentration, right? But what is V? V is nothing but V can be taken as V1 plus V2. Now, what is N1? N1 is equal to C1V1. N2 is equal to C2V2. Now, let me stop. If you started your calculation by trying to substitute N1 and N2 here with the given information, what is the given information? You've been provided that the information that you have a 15% acetic acid solution. This is solution 1. The concentration is 15%. What does that mean? 15 grams of acetic acid solute in 100 grams of the solution, right? And the second solution is 3% acetic acid. What does that mean? 3 grams of the solute CH3COOH in 100 grams of that solution. So one way to tackle this question would be to find out the number of moles of acetic acid in each of these solutions. You have the mass, you know the molar mass. So 15 by 60 would be the number of moles of acetic acid in solution 1. 3 by 60, the molar mass of acetic acid being 60, 3 by 60 would be the number of moles of acetic acid in solution 2. But that would have made the numerical involving too many numbers. So we are doing it in a very simple manner. So let's go back to the second board here. So now what we are going to do is we are going to substitute this data in the final formula. So now N1 plus N2. So C1V1 plus C2V2. All right. Divided by V1 plus V2 is equal to the final concentration. Okay. We can modify this further. C1 V1 plus C2 V2 is equal to C into V1 plus V2. Now let's substitute. What is C equal to? Now C1 is equal to 15%. Concentration is expressed in mass percent into V1 plus 3% into V2. So we are not converting it into moles. We are retaining the concentrations as given in the question. And you're also provided with the concentration of the final solution, which is 10 by 100 into V1 plus V2. We can immediately cancel 100, right? After we cancel 100, the solution becomes extremely simple. 15V1 plus 3V2 is equal to 10V1 plus 10V2. So we have 15V1 here, 10V1 here, therefore 5V1 is equal to, we have V3, V2 here and 10 V2 here. So 7 V2. So now what is the volume ratio? V1 by V2 is equal to 7 by 5. So what is the ratio? Ratio would, so V1 is to V2. The ratio would be 7 is to 5. So that is the final answer to this question. We solved this without using the number of moles, without substituting the values required for number of moles. So this solution was very easy, right? So let's go back and see which option suits this particular information. So we have option B as the correct answer. 7 is to 5. All right. Here is question number 12. 0.1596 gram of a metal oxide X2O3 is completely reduced to the metal X by 6 milligram of hydrogen gas. The atomic mass of the metal is. Again, a simple question, but this can also be done in a very simple manner. All right. So this is a question which will appear in section B of your exam paper, which is a numerical value type question. All right. So you have to arrive at a correct number, correct answer or an integer for this particular question. Okay. So let's first write down the equation corresponding to this reaction given here. So what is the equation? The equation would be X2O3 is reduced by hydrogen to give you the metal X plus water. Okay, let's balance the equation first. 2, therefore 2x. And if I put 3H2O here and 3H2 here, this equation is balanced. Now let's see what is the data given in this question. You are provided with the mass of X2O3 and the mass of hydrogen gas. So we are going to focus on X2O3 and hydrogen. All right. Now, you notice that X2O3, X is the unknown element whose atomic mass has to be determined. You're provided with the mass of hydrogen gas, right? So now, we using the given masses, let's start with 0.1596 grams of X2O3 completely reacting with 6 milligram. Don't forget to convert it to grams. 6 into 10 to the power of minus 3 grams. This is the data given to us in the question. Okay. Now, we know the mass of 3H2, which is 3 into 2, the atomic mass of hydrogen being 1, molar mass of hydrogen gas being 2, 3 into 2, 6 grams will give you how many grams of X2O3. So let's find out the mass of X2O3, which reacts with 6 grams of hydrogen. All right. So now we have X is equal to, that happens to be the molar mass of X2O3, because here you have 1 mole of X2O3 and X happens to be the mass of 1 mole of X2O3, which is the molar mass. 6 grams happens to be the mass of 3 moles of hydrogen. Okay, so what is the molar mass? Cross multiply 0.1596 into 6 divided by 6 into 10 to the power of minus 3. You can cancel this 6. So what do you get here? 159.6 grams would be grams per mole would be the molar mass of X. Correct? You have got 1596 into 10 to the power of 3. So it becomes 159.6 grams per mole is the molar mass. Now what do we do? Now we write X2O3 is equal to 159.6, or 2 into atomic mass of X plus 3 into atomic mass of oxygen is 159.6. 2x plus 48 is 159.6. 2x is equal to 159.6 minus 48. So what is that? You have 111.6, right? So what is x equal to? So here we have 2x is equal to 111.6. So therefore, x is equal to 111.6 divided by 2, which is 55 point. So you have 2 5s are 10, 2 5s are 10, and then you have 55.8 is the atomic mass of X. So which element would that be? The element would be iron. But you need to identify the atomic mass, obtain the atomic mass, which is 55.8. If you have rounded off this to 160, you would have got a whole number here. Okay, but you anyway, both the numbers are accepted. You get 55.8 as the final answer. So the answer to this question would be 55.8. All right, so that is how you solve this question. If you have found this video useful, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is given in the description below. See you tomorrow.